Welcome to the Virtual Driving Center at Bosch. Here we use computers to simulate a wide variety of driving situations to continually advance Bosch automotive technology. As a driver, you surely know the problem. Parallel parking with only a hunch to go on. The windows too small, the car's rear too high, your view blocked. In the side view mirrors, nothing that might be of help. And isn't the parking space much too small anyway? Enough. The intelligent parking assistant from Bosch puts an end to all that. Now you can master the art of parallel parking with ease. No more hefty cranking on the steering wheel, as your car moves comfortably into any suitable parking space. An ultrasound sensor automatically measures the length and depth of the space as soon as you drive past and with no help from you. When the system gives the signal for a suitable parking space, you just press a button, and the intelligent parking assistant calculates the best possible approach and automatically steers the vehicle into the chosen parking space while slowly backing. Although you operate only the gas and brake pedals, full responsibility still always rests with you. Several warning stages give you constant updates on the distance remaining between your vehicle and an obstacle. That way you always know exactly how much space is still available. Long or unsuccessful parking maneuvers are a thing of the past with the intelligent parking assistant from Bosch. With it, you can enjoy relaxed, stress-free parking.
Bosch. Invented for life.
Welcome to the Bosch Virtual Driving Center. Here we use computer simulations of a wide variety of driving situations to continually further develop automotive technology. The parking brake is an important contribution to safety as well as to comfort. So the Bosch International Development and Production Association has also further developed the parking brake. The result is the automatic parking brake, APBMI. The APBMI creates synergies with the Electronic Stability Program ESP from Bosch by integrating the parking brake electronics into the ESP. It also enables a variety of additional functions. The electronic parking brake mechanism ensures that it always establishes a precisely defined clamping pressure. The first thing we notice? No handbrake lever. That means that the middle console can be more individually customized. The APBMI is operated simply and easily with this button, release and apply again. The APBMI releases completely automatically and very comfortably when you drive off, taking into account the current tilt of the vehicle, pedal position, and coupling and transmission status. Automated vehicle hold is the second function that's available thanks to APBMI. When you stop on an incline, the vehicle is held hydraulically via ESC. This function prevents the vehicle from unintentionally rolling forwards or backwards. As soon as the driver leaves the vehicle, APBMI automatically ensures with its electromechanical parking brake system that the vehicle is kept in place. The parking brake must also allow for dynamic braking action in emergency situations. This is also required by law. Using the handbrake lever for this can be risky business because too much manual pressure locks the back wheels, immediately destabilizing the vehicle. Here too, APBMI also provides a considerably higher level of safety. When activated while driving, the system brakes the vehicle in a controlled manner, bringing it to a full stop without wheel lock, either hydraulically with ESC or mechanically via an APBMI integrated anti-lock function. The sensors integrated into the automatic parking brake monitor the brake pads for wear and tear. When a brake pad change is necessary, the driver is alerted by a wear warning lamp on the dashboard. APBMI can be used in combination with brakes featuring various caliper guiding systems. That means that the system can be used for light as well as heavy passenger cars. At our locations across all continents, we're working to ensure perfect application and manufacture in the highest Bosch quality.
Bosch. Invented for life.
Welcome to the Bosch Virtual Driving Center. Here we use computer simulations of a wide range of driving situations to continually advance automotive technology. In a critical braking situation, every centimeter can be crucial in determining whether or not a crash will occur. Accident analyses have revealed that although many drivers react very quickly, they do not brake hard enough. The EVA mechanical brake system from Bosch, which is incorporated into the brake booster, recognizes emergency braking from the rapid application of the brake and helps the driver to build up maximum braking force. To explain how the EVA mechanical brake assist system operates, let's start by taking a closer look at a brake booster. Brake boosters are designed to increase the driver's pedal force. This increase is achieved through pressure differences. Inside a brake booster are two chambers, A and B, which are separated by a movable diaphragm. When the brake is not in use, there is a vacuum in both chambers. A spring pushes the diaphragm into the brake's initial position. When the driver applies the brake pedal, ambient air flows into the rear chamber B, causing higher pressure to build up in front of the diaphragm plate. A pressure difference thus develops between front chamber A and rear chamber B, which pushes the diaphragm plate toward the master cylinder, enhancing pedal force. In the case of standard braking with constant pedal force, counter pressure in the master cylinder brings the operating rod and the valve piston into equilibrium. Ambient air continues to flow into chamber B through the open valve and pushes the diaphragm plate toward the master cylinder. Now the reaction disc causes the valve piston to come to rest on the flat seat valve, stopping the supply of ambient air. Thus the brake assist system is self-regulating. In a full braking action, the valve between atmosphere and chamber B is completely open, creating atmospheric pressure in chamber B, which allows the maximum possible auxiliary force to be transferred. In the case of emergency braking, this means that the more ambient air flows in, the greater the pressure in chamber B, and the greater the braking force. At this point, an inertia-controlled valve, which is part of the EVA brake assist system, comes into play. If the brake pedal application speed exceeds a specific value during emergency braking, the valve immediately opens the connection between chamber B and the atmosphere, as it does for full braking. Independent of the driver's brake pedal application, within fractions of a second the full pressure difference takes effect, providing maximum enhancement of braking force until ABS actuation. The result of a comparison between an ABS vehicle with and without a brake assist system speaks for itself. The stopping distance can be reduced by up to 60%. The EVA mechanical brake assist system from Bosch enables a significant improvement in road traffic safety, and it achieves this at a very low cost. Furthermore, with a simple component modification, the system enables compliance with the planned European guideline for pedestrian protection.
Bosch. Invented for life.
Welcome to the Virtual Driving Center at Bosch. Here we use computer simulations of various driving situations to innovate automobile technology. Today I'd like to introduce you to our new innovation, BO Plus, the first rear axle brake caliper with integrated parking mechanism for passenger cars and light commercial vehicles of up to 4 tons total weight. BOO Plus is based on proven technology in the passenger car sector, the Bosch ball and ramp. The brake caliper of the BOO Plus, however, was especially designed to meet the demands of light commercial vehicles. The result? 40% more clamping force than a conventional passenger car parking brake without the BOO Plus system. But that's enough theory. Please join me now on a test drive. Now, I'll just release the parking brake. And we're off and running. Looks like a traffic jam up ahead. Due to the high effectiveness of the BOO Plus parking brake, it's very easy and comfortable to apply. Hard to believe that with just a simple movement like this, I can produce a clamping force of 21 kilonewton. That guarantees that any vehicle can be safely immobilized, even uphill. But that's enough talk. Time to get moving again. Someone's having trouble getting started. Okay, let's go. The integrated ball and ramp mechanism from Bosch is, of course, compatible with ABS and ESP systems. In dangerous situations... Oh! That was a dangerous situation. And that means the BOO Plus just helped to prevent a major accident. That was quite an exciting tour. Oh, and about the lifespan. The BOO Plus withstands 130,000 instances of full braking with a maximum payload, with no change in efficiency and no loss of performance due to wear and tear. So a driver who makes 10 full brake applications a day, 365 days a year, can be assured of 35 years of unrestricted functionality. And that means that BOO Plus can certainly outlive any vehicle.
Bosch. Invented for life.
Take time for yourself. Just a moment or two, yeah. For you. One moment for life, a moment for you. That very moment can change your life.
Bosch. Invented for life.
Is it innovative to invest over 75 years in a millisecond? Yes, when this single millisecond is repeated a billion times. Lower emissions, less CO2 through lower consumption, more driving pleasure. That is modern diesel with diesel technology from Bosch. Bosch, invented for life.
Welcome to the Virtual Driving Center from Bosch. Here we use computer simulations of a wide range of driving situations to continually further develop automotive technology. For over 80 years, Bosch has played a decisive role in advancing diesel technology. That's progress to take pride in. Today's diesel engines are cleaner, more economical, and more fuel efficient than ever before. With its wealth of know-how and systems competence, Bosch continues to write the diesel success story, from the smallest to the largest engine application. Our staff's energy and passion for innovation, combined with our long-standing relationships with our partners in the automobile industry, have made Bosch the world's largest vehicle component supplier and the technology leader in the area of diesel. Since its launch by Bosch in 1997, the common rail system has virtually become standard equipment in all diesel passenger cars. Today, Bosch has suitable common rail systems for every passenger car. For all vehicle segments, Bosch supplies a wide range of injectors, rails, high-pressure pumps, and control units. These can be individually combined to suit the requirements of any vehicle. The Common Rail System CRS 1.1 is an example of a compact car diesel system from Bosch. The compact system was developed specifically for low-priced vehicles and is used in the world's first low-priced diesel, the Indian car Tata Nano. The system, with solenoid valve injectors, is designed for injection pressures of up to 1,450 bar. The pressure is created by a low-cost plug-in pump. Controlled by a special version of the control unit EDC-17, the CRS 1.1 complies with India's emission standard BS4, which is roughly the equivalent of the European Euro 4. CRS-1 systems can be based on either plug-in pumps or radial piston pumps. The CRS 2.5 is one example of Bosch common rail systems deployed in passenger cars with 4 to 6 cylinder diesel engines. Its injectors feature quickly switching solenoid valves that allow for multiple injections. The injection pressure regulated by fuel metering unit and pressure control valve can reach 1,800 bar. The CRS 2.5 is thus suitable for engines that already comply with the European emission standard Euro 6. In addition, the system has rapid start capability and can be combined with fuel-saving start-stop systems. The CRS 5.1 is an example of the common rail systems from Bosch deployed in upmarket diesel passenger cars. Its injection pressure of 2,200 bar is higher than that of any diesel system to date. The increased pressure levels enable the realization of downsizing concepts. Through downsizing, the same performance can be achieved with less engine displacement, thereby helping to achieve lower fuel consumption with decreased CO2 output without any concessions to sporty performance. To handle these high pressure levels, the CRS 5.1 is equipped with piezo injectors. Piezo injectors deliver consistent performance levels with reduced hydraulic nozzle flow. That in turn contributes to lowering emissions and reducing combustion noise. 30, 25, 50. That's the formula for saving money, protecting resources, and having fun. Economical. The diesel engine consumes more than 30% less fuel than an equivalent gasoline engine. Clean. The diesel engine produces around 25% less carbon dioxide than a comparable gasoline engine and thus holds top rankings for low CO2 output in all vehicle classes. Powerful. The diesel engine delivers about 50% higher torque than a comparable gasoline engine, even at low engine speeds. Yet diesel operation remains comfortable, quiet, and smooth. And development never stops. The diesel engine has enormous potential for the future. In the near future, new Bosch components for engine management and injection, innovative engine solutions such as downsizing, start-stop, and down-speeding, and various types of hybrids will bring additional fuel savings of 25 to 30%. Diesel. Invest with us in the future. Economical, clean, powerful.
Bosch. Invented for life.
Welcome to the Bosch Virtual Driving Center. Here we use computer simulations of a variety of driving situations to constantly further develop technology for the automobile. Today I'd like to present to you the Bosch systems for hybrid and electric vehicles. The powertrain electrification represents a considerable contribution toward making cars even more economical and environmentally friendly. Over the next 20 years, highly developed internal combustion engines will dominate the automobile market because the constant further development of gasoline and diesel systems during that period will make the biggest and most economical contribution toward the reduction of fuel consumption and CO2 output. But today's hybrid systems already represent the first step in the electrification of the powertrain. Hybrid vehicle technology creates potential for fuel savings and independence from dwindling fossil fuel resources, and CO2 output will also be further reduced. Bosch now already has the technology for drive units that are entirely electric and produce no CO2. Over the next 10 to 20 years, technological progress, the increased marketing of electric vehicles, and an expanding battery charging station infrastructure will see electric vehicles become an economical alternative to internal combustion engines. The hybrid drive unit is a combination of combustion engine and electric motor. In certain driving situations, the electric motor supports the internal combustion engine. Do you hear something? No? I don't either. That's because the hybrid control unit from Bosch has switched the engine off. The vehicle is no longer consuming any fuel. Let's take a closer look at that process. A hybrid electric vehicle combines an internal combustion engine and an electric motor in a single propulsion concept. This is the electric motor. It has two functions. As a motor, it drives the vehicle electrically. As a generator, it produces electrical energy and charges the battery. The connection between the electric motor and the battery is the inverter. It converts the direct current of the battery into the alternating current used by the electric motor. When driving electrically, the battery supplies the electric motor with energy. The battery is recharged during braking and when driving with combustion engine. Braking action releases a lot of energy. The cooperative regenerative braking system from Bosch ensures that as much braking energy as possible is